This video is on applications of exponential functions. Before we get any further, you need to understand the symbol E in pre-calculus and calculus concepts. E is called the natural exponent. E is actually a constant, kind of like pi in geometry. It's an irrational number that goes on forever. But the function f of x equal to e to the x is called the natural exponential function. So you do see that quite often in pre-cal concepts, or we're talking about exponential functions. If you're using your calculator, the E button is the inverse or second function key of the button that says LN. If you see the LN on your calculator, the inverse or second function of that would be the E button on your calculator. World population in millions closely fits the exponential function f of x equals 6,084 times e to the 0.012x, where x is the number of years since the year 2000. The world population was about 6,853 million in 2010. How closely does the function approximate this value? Well, let's see. If I were going to plug for 2010, I would actually say 6,084 times e to the 0.012 times 10, because we said x was the number of years since 2000. So 2010 would have been 10. So that actually gives us 6,084 times e to the 0.12. Now that's going to approximate on my calculator. So I'm going to multiply 6,084 times, I will put 0.12 second function ln equals, and I get 6,859.7, so million. So was that close? The world population was about 6,853. This is 6,859. So in this case, the model that we were using actually overestimated a little bit, but it's still pretty close to it. Pretty close. Use this model to predict the world population in 2020 and 2030. So let's see what we could get from 2020. That would be 6,084 times e to the, let's say, 0.02012, times 20. So that comes out to be 0.24. So using my calculator, I would say 6,084 times 0.24 second function ln button equals, it's saying 7,734.3 million. And for this would be in 2020. So in 2030, let's see here, 0.012 times 30 is 0.36. So 6,084 times 0.36 second function e button equals 8,720.4 million. Notice these are just estimations though. And this one would be in 2030. One model that you use quite often in algebra and in finance is the compound interest formula. The amount accumulated in a compounded account is equal to the principal, the amount of money that you start out with, times 1 plus r over n, all to the power of n times t. R stands for the interest rate, which is a percentage normally, and you would change that to a decimal. N, in both of these places, stands for the number of times that your interest is compounded in a year. So if it says annually, that would be 1 time per year, so N would be 1. Semi-annually would be 2 times in a year. Quarterly would be 4. Weekly would be 52. So it depends on how many times you compound in a year. And then T, of course, is just the time in years. So the formula is A equals P, the principal, times 1 plus R over N, all to the NT power. Let's use that formula. To calculate compound interest. Find the total amount of money accumulated at the end of the indicated time period for the following investment. You're going to invest $750 for 6 years at 8.25% compounded quarterly. So the amount would actually be, the principal is $750. The interest rate, 8.25%, would be 0.0825. If it's compounded quarterly, that's 4 times in a year. So you're going to divide that by 4. And then it's going to be 4 times the number of years, which is 6. So let's work this out a little bit. 750 times 1 point. Divide on your calculator 0.0825 divided by 4. And I got 0.020625. And that will be to the 24th power. So again, your exponent key on your calculator may be the caret symbol, or it may be like y to the x, one of those type buttons. So the approximate amount of money, and since it's money, I'm going to round off to the nearest cent. That would be 750 times 1.020625, exponent key, 24, equals. So at the end of that 6 years, I have $1,224.19. If the problem says that you have compound interest that compounds continuously, very specific in the wording there. If it says compounded continuously, then you use a special formula. I call this the PERT formula. The amount equals the principal times E, which we know what E is now, to the RT. So the PERT equation, E to the RT. Find the total amount of money accumulated at the end of the indicated time period by compounding continuously, notice the key word, for the following investment. $3,500 for 5 years at 5.5%. So remember, my formula is going to be P times E to the RT power. So the amount we're going to have here is going to be 3,500 times E to the 0.055 times 5 years. So 0.055 times 5 comes out to be 0.275. So all I have to do now is just punch this into the calculator. Again, it's money, so we're going to round off to 2 decimal places. 3,500 times 0.275, second function key E, equals, I got $4,607.86. Always round off to